Welcome to the world of data structures. Our today's topic is linked list and the memory representation in linked list. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, first today we are going to learn about what do we mean by the linked list. What is the actual use of the linked list? Then the concept of the linked list and the memory representation of linked list. Fine. So let's begin to understand that what is linked list. So students, the linked list is a collection of nodes where each and every node contains two things. Remember, do not forget this. Linked list is a collection of nodes where each and every node contains two things. One is data, one is pointer. So when I take a node over there, it contains one data and one is a pointer. So the collection of this particular thing is called as node, and when I combine such type of nodes together, okay, then it becomes a linked list. Okay, so here the nodes in the linked list are not contain continuous memory. Okay, so what does it mean? Students, if you remember about the array, then if I'm taking an array integer a of 5, so if the address of the first element a of 0 is 1000, the next must be 1002, next 1004, next 1006. So it's go like this. But when I talk about the linked list, if my first node address, remember repeating this, the first node address, here I'm not talking about the elements, here I'm talking about the nodes which contains data element and pointer both. Fine. So here the address of my first node is 500, then next node can be 1000, 2000, 300, 250, 4000, anything else. So it is not definitely sure that all the nodes of the linked list are in a continuous memory fashion. But although it's a linear linked list, or we can say it's a linear data structure. So why? Let me tell you. Before that, please talk about the types of the linked list. So the type of the linked list, when I say the first one is a singly linked list. So students, here you can see the singly linked list. See, the particular one node is connected with another node with a link. Okay, that link is known as a pointer. Now, when we talk about the singly linked list, the link of the last node, or we can say the pointer of the last node, is pointing to null. What happens over here in linked list? If you remember the compartment of the trains, right? The one compartment contains the passenger, another compartment is contains a passenger. So what happens over here? The compartment number 1, compartment number 2, compartment number 3 in train. All these compartments are connected with each other with a link. Okay, so that link and that compartment is the best example to showcase the linked list real-time example for you all. Why? Because the passengers sit in the compartments, the passengers that are in the compartments are can be known as a data, and the link which is connected between the two compartments is known as a pointer. Fine. So what happens over here? This type of things, if you can say this, the one compartment is connected with another compartment with a link. Okay, so here what happens? My node contains the two things. One is data, one is pointer. Where the pointer of a node is going to point the other node of the list, or the next node of the list. Fine. So what happens if we reach to the last node in the single linked list? Then you can easily say that the last node of the single linked list. So what next of the last node? Nothing. So that's why the last node, the pointer of the last node of the list is pointing to null. Fine. Now, what the next example is? Students, next example is a circular linked list. If I'm talking about the circular, see in the above figure and the second figure, in both figure you can check out the how the circular linked list look like. See, when we talk about the circular cube, what happens over there? The last pointer, sorry, when we talk about the circular cube, what happens over there? The element, the last element is connected with the first one. Again, repeating this, the last element is connected with the first one. So students, same like that here in the circular linked list, the link of the last node, I'm repeating this, the link of the last node is directly connected or pointing to the first node of the list. So when the last link is connected, the link of the last node is connected to the first node, then such type of linked list is known as circular linked list. So another linked list we have that is known as a doubly linked list. This doubly linked list, what happens over there? Let me show you. See, this is a figure of a doubly linked list. This is a figure of a doubly linked list. If I can say that the node contains two different pointers. See, in circular and in singly linked list, in both of them, a node contains only one pointer, okay, which is pointing to the next node of the list. If there are no nodes in singly linked list, then it pointing to the null, and the last node of the circular linked list pointing to the first node. But what happens over here in the doubly linked list? Here, students, we have two different pointers, which are known as a left pointer and a right pointer. So students, here right now in doubly linked list, my node contains how much things? Three things. One is data and two other pointers. One is data and two other pointers. One is data inside the node, second pointer. Okay, so first the pointer is a left pointer which is pointing to its previous node, and the right pointer is pointing to its next node of the list. If your node does not have any left or right nodes, then both pointer are pointing to the null. Fine. So these are the types of the linked list. Now, let's understand the concept of the linked list, that when I say that student, the linked list is the collection of nodes, but what exactly mean by the node? Okay, so let me show you. Here it is. The node is equal to data plus pointer. I want to say that the node contains the two things. Again, remember, keep this in your mind that node contains two things. The one is data. The second one is pointer. Fine. So here if you can see this particular my data plus pointer. Data plus pointer, this all combination is known as node. Fine. Now, when I talk about a data and pointer combination is known as a node. So here is a node which contains data A. Data A. Now, so here I'm taking one node where A is the data and the arrow. Arrow is known as a link. Arrow is known as a link, or we can say a pointer. Students, the first node of the linked list is pointed by first pointer. Repeating this, see, the new word for you is the first pointer. So students, just tell me that what is top? Top is a pointer, right? Which is pointing to the topmost element of the stack. Fine, good. Now, what do we mean by the front and the rear? So front is a pointer which is pointing to the first element of the queue, and rear is a pointer which is pointing to the last element of the queue. So what do we mean by the first over here? First is a pointer which pointing to the first node of the list. In many of the cases, students, you may found like head or start, but here I use first to represent a pointer of my first node of the linked list. Fine. So here I'm saying that A is my first node which is pointed by the pointer first. Now, so first is a pointer which is pointing to the first node of the list. Okay, and it stores the address of the first node. Okay, what happens over here? See, what does a pointer do? Can you tell me what does a pointer do? So pointer stores the address. Okay, if the pointer P points to node A, that means P stores the address of A, that where the A is located. Correct? If I say the integer A, okay, the integer star P, if I write like integer A and integer star P, and P is equal to ampersand A, that shows that P stores the address of the A. That's why we can say that the P is a pointer which is pointing to the element A. Okay, so obviously pointer is used to store the addresses. Here right now the first is a pointer. First is our pointer which is pointing to the node A. That's why we can easily say that the first stores the address of the first node of the linked list. Here, let me complete my linked list. Let me show you how it looks like. So here is a node B and the null. See, this is my singly linked list. This is my singly linked list. How? Because the B is the last node. B is the last node and the pointer of the last node is pointing to the null. That's why it's known as singly linked list. Fine. Now, let's move further. So, what does it mean? B is a node. Fine. Now, next. Students, memory representation of linked list. This is very important theory for you, that how the linked list stores in a memory. So let me take a singly linked list for you all. The first element is 10. Okay, first element is 10. The first is a pointer which is going to point the first node of the list. So here it is. The first is already pointed to 10. Then we have 20, 30, 40 and 50 with us. There is no node after 50. That's why the last node, that means 50's pointer, is pointing to null. Okay. Now, let me give you the basic example of the addresses. Just imagine a situation where the 10 address is 1010. The address of the 20 is 1360. The address of the 30 is 1250. The address of 40 is 1400. And the last, the address of the 50 is 1310. Here, students, if you can see, there are no nodes in a continuous memory fashion, because this is a linked list, not an array. Okay, so here all nodes are connected with each other. Yes. So is this a linear linked list? Sorry, is this a linear data structure? Yes. How? Because if you can say, see, the 30 contains only one predecessor, that is 20, and one successor, that is 40. 30 contains one predecessor, that is 20, and one successor, that is 40. That's why it's a linear linked list, or we can say linear data structure. Fine. Okay. Now let's move further. See, whenever I am trying to represent a linked list, I need two different arrays. Okay. One stores the data, another stores the links. How? Let me show you. Just consider the above linked list, and here I am representing the linked list by using two different arrays. Okay. So the memory representation of linked list maybe look like this. Here, if I can say, these all are the memory sections. Okay, the data array contains all the memories. If you may found that 101, 1008, 1010, then it must be, sir, 1012, then 1014, 1016 if it is an integer. Okay, then 8, 10, 12, 14, 16 must be like this. Then why are you skipping the numbers between of them? So students, I am just imagining a data in the memory which is a continuous memory fashion. For the example, I am not able to write each and every address. Okay, that's why I am showing you only the important address which are covered in our example. Okay, so here obviously you are correct. After the 1010, we have 1012, 1014 up to 1044, 1244, 1246, 1248. Yes, students, we have. But I'm not able to show each and every memory address right now. That's why I put one line between of 1248 and 1010. That line shows that dot. Okay, 1010 dot 1248. In between of this, all the memory addresses are exist, but we are do not able to show it. So let me start with our very first data, that is 10. Students, can you tell me what do we mean by the first? First is a pointer which is pointing to the first node of the list. That means it stores the address of the first node. It stores the address of the first node. Okay. So what is our first node? Our first node is contains the data value 10. Okay. Good. Now its address is 1010. That means let me create the first. See, here is the first which is going to point 1010. Again, see, the first, it is going to point 1010. Fine. Now, at that location 1010, we should put our data, that is 10. As you can see, students, that the first pointer is pointing to the 1010 location, right? So now the data at the 1010 memory address is 10. Okay, now what happens next? See, the first node is going to point to the next node. Can you tell me what do we mean by the node? And in the node we have data in the pointer. So students, you just need to take the 10 and then take the exactly the same memory address in the same direction. So it is 1360. If now your link array is going to be used, see, we have data, we have link, we have data, we have pointer. In data we put 10. Now the pointer is going to point the next node, pointer is going to point the next node, and now here the next node of the linked list contains the address 1360. That's why its value is going to be stored in the memory of in the pointer value of the first node. Fine. So the second node starts from the 1360. So obviously the link is going to point 1360. If you can see 1360, it goes like this. Fine. So it's going to point the 1360 location. At that location we have 20 value. 20 value. Let me just insert the 20 over there. Now tell me, what is the next node? Next we have 30. Okay. What's the address of the 30? What is the address of the 30? Address of 30 is 1250. 1250. That means the value which is going to be stored in the link of 20 is 1250. So here it is. The link of the 20 we have 1250. So the link of the 20 is going to point the 1250 location. So here it is. 1250. Fine. Now what next? Next, students, we have the 40 with us. So obviously after inserting 30 we have 40. Now the address of the 40 is 1400. That means the 1400 is the next node address. So in the beside or in the link column we need to put 1400 data. Now after doing this, the last one is we have the 50 students. So let's move towards the 50. Let me insert first 40 and then move towards the 50. The location of the 50 is 1310. So in the link column I need to write down 1310. Now tell me, is there any node left after 50? Is there anything next after 50? No. So this is my 50 which is at 1310. Fine. Now after this there are no nodes. That means the link of the 50 must point to null. So I'm going to do the same. So here it is, the link in the link column. I am just write down null over there. Students, that shows there are no nodes after 50. Fine. So what I'm going to do over here, first I'm going to make a column of data. That means array of data, array of link. Each and every array of link and data have the same located memory addresses. Fine. Such type of data. Now first let me start with the address, that is known as the first. Okay. The data column contains the value and the link array contains the value of the next node. Fine. So such like this, students, you can represent your linked list in memory. This topic is known as memory representation of linked list. So that's it for today's lecture, students. If you have any doubt, then please feel free to ask me. Thank you so much.